So continuing on with lesson 115, this will be 115B in Algebra 2, and we are on example 115.3. So we're going to use the same formula, equals A, okay? And it says in the beginning there were 4.25 ounces of radioactive material in the beginning. That means that number is going to go there. It decayed exponentially. Okay, so it's decaying. It's getting smaller, less. All right. 10 years later, 3.92 ounces remained. How much would remain after 30 years? All right, so let's go ahead and fill in our blanks here. So we have 4.25 and we said 10 years. So again, we're looking for K, so we're looking at what they're giving us, and in 10 years we have 3.92. So again, we're looking for K, and then we will plug in the 30 years instead of the 10 in this place right here. Okay, so let's get going here. We are going to take, because of the E here, we're going to take the ln of the 3.92. No, we're not. We're going to divide this first. I didn't even see that there. Alright, so we're not taking the ln of 3.92. We're going to take the ln of 0.9223. And that, one of the things that is important as far as logarithms is make sure there's just an E here and there's just a number here. There's not a whole bunch of other stuff in the way. See, here we had this 4.25. Can't really do anything until that disappears. So we divide it by both sides. Now we're going to take the logarithm of 0.9223, and that's going to give me my exponent to put on E, which in this case will be negative 0.08. Okay, now that I have E's on both sides, so my K then is going to be, let me do something else here. My K is going to be negative 0.008. Okay, so the only reason I did that is to find K. Alright, so now I'm going to write my equation. Okay, so now I'm going to start filling in blanks. So my A of O is going to be my 4.25 again, because that didn't change. Okay, so let's just put in parentheses there. And I'm interested in a time. So there's my general formula. What is my radiation going to look like as my time changes? All right, in this case, they want to know in 30 years. So my time is 30 years. That's going to equal 4.25 E to the negative 0.008 times 30 years. So I'm going to multiply those two, and then I'm going to take the anti-log of that, and when I do that, you should get 0.7866, so anti-log would be e to the x key, and then I've got 4.25, and when I multiply that, I should get my a to the 30th, and in this case, I get 3.34 ounces. Okay, because that's the ending that they gave us. Alright, so that is example 115.3. Now let's go down to 115C, where they're talking about compound interest here, and we'll try some of those. Alright, so we put money in the bank, and when we put money in the bank, it gives us a certain amount of interest. We make money off of it. But we need to know sometimes how much money. So let's say that you put in $100. Okay? and it gives you 8%, and it determines that you make 8% once a year. So at the end of the year, they take 8% of $100, $8, and they give you your $100 back and the additional $8. What that means is they had $100 in their bank that they could loan to other people and make money off of. So let's say that they loaned that money for 15% to somebody else. So they made $15 off of your 100, and at the end of the year they're willing to give you some of that profit back. So they give you $8 back and they keep 7. So that's how a bank makes money, is they give you interest on the money, but they lend it to other people. So, and then make more money off of it. So they're making more money off lending it to other people than they're giving you. So that's where they get their profits in their big buildings. All right, so we are going to come up with a formula. And this first formula has to do with compounded annually. That means at the end of the year, they're going to determine how much money they're going to give you. So we have the total amount, means the interest in the amount you gave them to use, or times the principal, which is the money you put in the bank, 1 plus r to the n power. And using this interest thing is where they came up with the e value of 2.8 whatever as far as natural logarithms go, but we're not going to get into that till next year. Alright, so let's say, for example, you put in 100. 1 plus the interest rate is 0.088% over the period of a year. So take 100 times 1.08 and you're going to get $108 is how much money you have. 100 that you put in there plus the $8 you get back. So they use that formula there for things that are compounded just one time every year. Sometimes they compound continuously. That means that every second of every day they're compounding. There's a different formula here. The amount given a certain amount of time, principal, E-R-T. So there's two formulas that we're going to use there, depending on whether it's compounded continuously or compounded annually. Now this example we're using here is compounded continuously, so we're not even going to use this one here. Alright, so let's move this up here. And let's look at example 115.4. Roger deposited $5,000, so the principal, the amount he put in there to start with. So he's going to get $5,000 plus interest. So we're going to remember that we're going to know that at the end here. And the interest, or the rate, was 7.5%. And change that to decimal, we have 0.075, because that's what we're going to use here. We always use decimals, we never use percent. How much money did he have in 10 years? Alright, so let's see what we've got here. We're going to use this formula, and we are going to say he puts $5,000 in, the rate, and what is our time? What does it say? How much money did he have in 10 years? See, there's no K here that we have to solve, so we just kind of plug the numbers in here, and makes it work a lot better. In fact, let's go ahead and change that T. We know it's a 10 now because the problem said in 10 years. So let's see what we can do here. We're going to multiply that first. Uh, 0.075 times 10 is going to be 0.75. Decimal place just moved over 1. Now we're going to take e to the 7.5 power. So what you're going to do there, we're given the exponent, so we're finding the anti-log here. So we got 0.75 shift e of x key, and we get 2.12. So I'm going to write this again as, so e to the 0.75 is the same as 2.12, and we multiply that out and we get 10,600 $5,500. So what does that mean? That means that Roger put $5,000 in the bank for 10 years, and when he went to the bank to get his $5,000 back, they say, we don't have your $5,000, but because you left that money in here for so long, you now have, instead of $5,000, $10,600. So you have your $5,000 plus another $5,600 in interest that we're going to give you. Thank you for letting us use your money to loan it to somebody else to buy a new car. Okay, so that's what happens there. So the key thing that probably is, I would imagine, is the struggle is getting from here to here. All right, so again, if you have an exponent, take the anti-logarithm. If you are looking for the exponent, take the logarithm. Okay, so anyway, that should give you a start there on lesson 115.